Hello everyone. Today our focus will be on understanding the intricacies of designing concrete mix proportions. Concrete mix proportions refer to the quantities of each constituent material in concrete and their related ratios. Determining these ratios is the core task of concrete mix proportion design. Concrete mix proportions can be expressed using two primary methods, mass ratio and volume ratio. In common practice, the mass ratio is used, which entails specifying the actual amounts of each component material in 1 cubic meter of concrete. For instance, cement is equal to 295 kilograms, sand is equal to 648 kilograms, stone is equal to 1,330 kilograms, water is equal to 165 kilograms. Alternatively, these proportions can be represented as ratios such as MC to MS to MG is equal to 1 to 2.20 to 4.51, and MW divided by MC is equal to 0.56. The design of concrete mix proportions is a crucial aspect of concrete engineering. It has a direct impact on the seamless execution of concrete construction, the quality of the concrete structure, and the overall cost of the project. The finalized concrete mix proportions, achieved through a process of calculation, tri-mixing, and adjustment, must align with relevant regulations and requirements. They must first meet the strength criteria, ensuring that the concrete can support the structural design or construction progress adequately. Second, they should cater to concrete workability, determined by factors like the cross-section dimensions and shapes of structural elements, the spacing of reinforcement, construction methods, equipment, and other considerations. Third, they should address the concrete's durability, taking into account the environmental conditions the components will be exposed to. This necessitates selecting the appropriate cement type, establishing the maximum water-cement ratio, and determining the minimum cement content. Lastly, economic considerations come into play. It is essential to ensure compatibility between the cement strength grade and the concrete strength grade while striving to conserve cement and make efficient use of local material and industrial byproducts. The guiding principle is to minimize concrete costs while adhering to relevant technical requirements. Now, let's delve into how we can formulate concrete mix proportions that meet these regulations and requirements. In the upcoming sections, we will introduce the methods and steps of concrete mix proportion design. We begin by performing preliminary calculations based on the known properties of raw materials and the technical specifications of the concrete. This process leads to the derivation of the theoretical ratio, which represents the initial mix proportions. Building upon the theoretical mix ratio, we proceed with laboratory testing, inspections, and adjustments to arrive at the benchmark mix ratio, ensuring it aligns with construction and workability requirements. Subsequently, we fine-tune these proportions for apparent density and strength to determine the laboratory ratio, which meets both design and construction requirements. Finally, we make on-site adjustments based on the actual moisture content of sand and stone to obtain the production mix ratio suitable for construction. Step 1. Determine the formulated strengths. We use FCU0 to indicate. First, when a standard value of concrete cubic compressive strength, i.e., the design strength grade value of concrete FCUK, is less than C60, the concrete formulated strength FCU0 is required to be equal or greater than the design strength grade value of concrete FCUK plus 1.645 times of sigma. Sigma is the standard deviation of concrete strength. It can be calculated according to the statistics of similar concrete to determine, but also according to the relevant provisions of value. 2. When a standard value of concrete cubic compressive strength, that is, the design strength class value of concrete FCUK, is greater than or equal to C60, concrete formulated strength FCU0 requirements are greater than or equal to 1.15 times the design strength class value of concrete. Step 2. Determine the water or cement ratio. We'll use MW or MC for this. When a strength class of concrete is not greater than C60, the water-cement ratio of concrete shall be calculated and determined according to the relevant formula. Formula alpha A, alpha B for the regression coefficient should be based on the cement aggregate through the test by the establishment of the relationship between the water-cement ratio and the strength of concrete to determine. When there is no test statistics, can be taken as crushed stone concrete alpha A is equal to 0.46, alpha B is equal to 0.07, pebble concrete alpha A is equal to 0.48, alpha B is equal to 0.33. It should be noted that, according to the conditions of the concrete use, the calculated water-cement ratio should meet the durability requirements for the maximum water-cement ratio. The calculated water-cement ratio and the maximum water-cement ratio for durability requirements for comparison take the smaller of the two values. Step 3. Determine the amount of water used per cubic meter of concrete. We'll use MW0 for this. Water-cement ratio in the range of 0.40 to 0.80 in determining the plastic concrete and dry hard concrete water consumption, according to the variety of coarse aggregate, particle size, and construction requirements of the concrete mixture of liquidity indicators to find the relevant table selection. Water-cement ratio of less than 0.40 and the use of special molding process of concrete. Its water consumption can be determined by test. In determining the water consumption of concrete with admixtures can be calculated according to the formula to determine, where MWA for each cubic meter of admixture concrete water consumption, MW0 for each cubic meter of unadulterated concrete water consumption. Beta for the water reduction rate of the admixture should be determined by the test of concrete. Step 4. Determine the amount of cement per cubic meter of concrete. We use MC for this. The amount of cement used can be found for the determined water consumption of the concrete and the water-cement ratio. The water-cement ratio is equal to the mass of water than the mass of cement, so that the mass of cement is equal to the mass of water divided by the water-cement ratio. It should be noted that, according to the conditions of use of concrete, the calculated amount of cement should meet the durability of the minimum amount of cement requirements will be calculated to determine the amount of cement and durability requirements of the minimum amount of cement for comparison. Take the greater of the two values. Step 5. Determine a reasonable sand rate. We use beta S to express. The selection of reasonable sand rate can generally be determined according to the unit's experience of use or through testing. When there is no historical information for reference, it can be determined by looking up the relevant table according to the type and a specification of aggregate and a water-cement ratio of concrete. It should be noted that this table applies to the concrete mix slump greater than or equal to 10 millimeters, while less than or equal to 60 millimeters. When the slump is greater than 60 millimeters, can be determined by test, but also on the basis of the table. The slump of each increase of 20 millimeters sand rate correspondingly increased by 1% to deal with. When the slump is less than 10 millimeters, the sand rate should be determined according to the test. Step 6. Determine the amount of sand and stone. We use MS0 and MG0 respectively. two methods can be used to calculate the quantities of sand and stone, the volumetric method and the mass method. In the volumetric method, assume that the volume of 1 cubic meter of concrete mix equals the sum of absolute volume of each constituent material and the volume of air contained in the mix. The volume of each constituent material is the ratio of its mass to its density. Additionally, with the help of the formula for calculating the sand content of concrete, you can establish a set of binary quadratic formulas for sand and gravel. By solving these equations, you can determine the quantities of concrete, sand, and stone. When using the mass method, first assume that the mass of 1 cubic meter of concrete mix is denoted as MCP. You can determine MCP based on cumulative experimental data, or in the absence of such data, select a volume within the range of 2,350 kg to 2,450 kg. Then, ensure that the cumulative sum of the amount of each constituent material per cubic meter of concrete equals the total weight of 1 cubic meter of concrete mix, which is MCP. Similarly, with the assistance of formula for calculating the sand content of concrete, you can establish a binary quadratic set of equations for sand and gravel. By solving these equations, you can determine the quantities of concrete, sand, and stone. With these 6 steps, you can determine the quantity of each component material in the concrete, which results in the initial proportions of the concrete mix. These proportions can be expressed in 2 ways. One is expressed in terms of the mass of each material in 1 cubic meter of concrete, and the other is expressed in terms of the ratio of the mass of each material related to the mass of cement, with the mass of cement set to 1. Concrete preliminary ratio of the amount of materials identified is calculated with the help of some empirical formulas and data, or use of empirical information to find a table, and thus may not be in line with the actual situation. It must be adjusted through the trial mix until the workability of concrete mixes to meet the requirements until, at this time, the ratio of the concrete obtained for the baseline ratio can be used as a test of the strengths of concrete proportions of concrete mix. Below, we will learn the test mix, adjustment, and determination of concrete proportions of concrete mix. The first step is the trial mix and proportion adjustment. When conducting a concrete trial mix, ensure that the minimum mix quantity aligns with the requirements of relevant regulations. If the maximum aggregate size is less than or equal to 1.5 millimeters, use a trial volume of 15 liters. For maximum sizes of 40 millimeters, use a trial volume of 25 liters. When using mechanical mixing, make sure that the mixing volume is at least 1/4 of the mixer's rated volume. When adjusting the workability of concrete, follow these guidelines. If the fluidity exceeds the required level, maintain the sand ratio while increasing the amount of sand and stone as needed. If the fluidity falls short of requirements, maintain the water-cement ratio while increasing the amount of water and cement as necessary. For pore adhesion and water retention, maintain the aggregate ratio while increasing the sand ratio as required. Concrete benchmark ratio is only to meet the requirements of workability, whether its strengths to meet the requirements, but also for further verification and determination. Calibration of concrete strengths, at least 3 different proportions should be used, one of which should be the benchmark ratio. The other 2 proportions of concrete mix ratio should be increased and decreased by 5%. Water consumption should be the same as the test mix ratio, and rate can be increased and decreased by 1%. It should be noted that the other 2 sets of ratios should also be tested, and adjusted for workability to ensure that all these sets of ratios can meet the requirements of workability. Next, the strength of concrete mix is determined, and at least one set, 3 pieces of specimens, is made for each set of proportions, and its compressive strength value is determined after molding and standard curing for 28 days. From the compressive strength value and the corresponding grade-water ratio, we can draw a graph of the relationship between compressive strength and grade-water ratio. From the curve, we can find out the grade-water ratio corresponding to the formulated strength FCU0, i.e., the grade-water ratio that meets the requirements of concrete strength. Below, we can determine the amount of material per cubic meter. 1. The water consumption is taken from the water consumption in a base mix ratio and adjusted according to the slump or vibro consistency measure when making strength specimens. 2. The amount of cement is calculated and determined by multiplying the water consumption by the determined new grade to water ratio. 3. Coarse aggregate and fine aggregate dosage should be taken from the coarse and fine aggregate dosage in a base mix ratio and adjusted according to the selected grade-water ratio. The specific calculation method is the same as the method of calculating sand and stone dosage when determining the preliminary mix ratio. It should be noted that, at this time, the sum of the volume of the 4 materials is not necessarily a cubic meter. Therefore, when the laboratory ratio is determined by trial mixing, but also to determine the actual apparent density and compare with the calculation of apparent density in order to carry out the correction of the ratio. In a correction of the proportion, a correction factor is used. The correction factor sigma is equal to the ratio of the actual measured apparent density of the concrete rho CT to the calculated apparent density rho CC, where the calculated apparent density rho CC is equal to the cumulative sum of the mass of cement, the mass of water, the mass of sand, and the mass of stone. When the absolute value of the difference between the actual measured apparent density and the calculated apparent density does not exceed 2% of the calculated value, the calculated mix ratio does not need to be corrected, i.e., it is the laboratory mix ratio. When a difference between the two exceeds 2% of the calculated value, the amount of each material is multiplied by a correction factor to determine the final amount of each material in a laboratory mix. In this way, the amount of each constituent material per cubic meter of concrete, i.e., the laboratory proportions of concrete mix that meets the strength requirements of concrete, is determined. Assuming that the moisture content of sand and stone in a field is 8% and B%, respectively, the material quantities per cubic meter for the construction mix proportions of concrete are as follows. The construction mix proportions can be expressed as These conclude the lesson. Thank you.